Hi everyone, welcome back to this series. Today I thought I'd cover a way, I wanted to find a way to track allocations and how much memory I'm actually allocating. And I didn't really find a way of doing that in the standard library, so I decided to make one of my own. I believe there's a thing in the standard library called logging, which basically tells you when you allocate, but it doesn't tell you how much. And so I thought I'd make my own, so I made this struct called tracking allocator. I'll just zoom in. I'm in VS Code just because it's easier just to follow stuff. So if you click on things, it takes you to the actual place. It's just easier. Uh, but anyway, so we have the struct, and it basically has an allocator with a pointer and a usize for basically how many bytes we've allocated. So that will count the amount of bytes we've allocated. We have all basically the exactly the same copies. We have alloc, create, free, destroy. The difference between allocate is that allocate will return a slice. Create will create just one thing. And then free will free a slice, I believe. Yeah, will free a slice. And then destroy will destroy the one thing. That's the main difference. I just have some debugging stuff which I can close. It's just so basically what I did was debug alloc will print the amount you've allocated every time. It's just easier to debug. And debug create is basically the same thing. Bytes allocated, you can just get the usize bytes allocated if you want, and you can print the bytes, print the bits, print the megabytes, which is annoying because it's a float and all this format nonsense. But anyway, so I was trying to make my own string type, and I ran into a lot of problems. Didn't really work too well. I don't really understand memory allocation well enough. So basically, what problem I had was imagine you want to concatenate, right? So you have a string, and you want to add something to a string. So you call a function, and then you add them together. You make a buffer. You add one, add the other, and then set it into the string, whatever. So I have this string class which just had a value, which is just the string you hold it, and I had this concatenate method here. I ran into a lot of problems because I kept getting memory leaks, or I would get like a deadlock where it would you'd free the memory and then you'd try to access it afterwards. Because the problem is, the way a slice works is actually it's basically a pointer. So you're pointing to memory, and if you create a heap memory in a function and you point to that, you're basically setting it to this, and you can't free it because you're pointing to it. So I actually don't know how to fix that problem, to be honest. But I realized that I wanted to see how I'm getting memory leaks, or if I'm getting a memory leak or not, and I use this. So I use the testing allocator, or I call it a tracking allocator, I guess. Tracking allocator. One problem is you do have to actually kind of change your implementation. You can't put an allocator, but you got to send a tracking allocator. So you got to include allocator, and you got to have the file tracking allocator.zig in this. But if I just show you this, let me see where main is if I'm running this. So yeah, I'm running this. So I'll run this and show what I'm doing. Let me just show the code. So here, testing strings run. So I had before, so I use the page allocator and put the page allocator into the tracking allocator because you need an allocator with it. And then basically when I call create, I call the allocator inside, and that's how it works. So we create print line, then we show the bytes, which should be 0 as it should be because it's just created. And then we go to this function, allocate to test, and we send this over. So let me zoom out. Let me make this smaller. That would be the easiest thing. Yeah, just close that. So we create the word as a pointer. It's basically a pointer to a struct. We create it, and the input will be testing strings. So it's just the name. The actual value will be testing strings. Then we defer it, so we're destroying it afterwards. Then we just print, I guess, the length of it, and then we just print line just because I don't have a. I'm not sure actually why I'm printing the line. Sorry, yeah, this is a function inside the string class. So print line, it just prints the string with a line, with a new line character. So we print whatever's in it, and we add something, and we print something else in it, and then we print the bytes. So I'm printing how many bytes we've allocated, and then I come back to the other function and print the bytes again after the defer. The problem is we actually do have a memory leak here, which I'll show you. So first we print the string, testing strings, we print that. and we allocated 59 bytes. So first we allocated 16 bytes, and then we allocated 59 bytes while creating the string, and then added it to this. So now the memory is 59, right? Then we free the original 16, which we allocated here, but we never free the 43 bytes, which I'm not sure exactly how to do that, to be honest, because it's just the way I've, where it's in concatenate end. So in concatenate end, we create a buffer, we add to it here, and then set it. I don't know how you would make a slice. Set it to nothing and then just set it to the values inside. I don't know how to do this without actually creating a memory leak but anyway, so this is just a good way to test. I'm obviously not good enough at managing memory to write my own string concatenator, but anyway, this is just a good way to test memory. So you can see the memory's freed, the memory's not freed. You know, it's a good way to test it, but you do have to kind of track it yourself. I'll just show you the code again for tracking this. So we have alloc. So we take in a memory allocator, take in the usize. Also, we have the create. So create or init. The init will take in the allocator and return a tracking allocator, and then we just put in 0 and the allocator. That's basically it. Then we have obviously the allocated bytes and the allocator. So when we alloc, we put in the type and we put in the number, and then we return the slice to that. Then with create, we just it shouldn't be a slice. I should rename that. That's a terrible naming thing. I should just say memory. Because it's memory, it's not a slice. Maybe it is a slice actually. Why would that be create? That doesn't make sense. Give me 1 minute. This is wrong. This should be T. Okay, I don't know why I wasn't getting errors for that. Maybe I wasn't actually using this, but anyway, the create should be a T and not a slice. So yeah, for free, we're just freeing. We're just calling free slice. That's all we're doing in the allocator, and we're just minusing the size of the length of the slice. Same here. When we destroy it, we're just minusing the size of the T, and then destroying it. That's basically it. So basically, we're using an allocator inside another kind of wrapper for an allocator. That's how we do this. But it's just a good way to debug. You can write one of these yourself. You can copy the code. And it's just, a useful way to know if there's a memory leak or if, how many bytes you're actually allocating. It can be an interesting thing to know. There's also a way, I had a way to, obviously print the different bits, bytes, memory, megabytes. In theory, you can make it, you can put gigabytes if you want, but anyway, it's just an interesting way to detect allocations and do it yourself. Let me know if you have any questions. I'll see you guys next time.